What is propellant used for in rocket launch stages? Imagine a rocket soaring into the sky, breaking free from Earth's pull. What makes that happen? It all comes down to propellant. Propellant is the fuel that powers each part of a rocket's journey. When burned inside the rocket engine, it produces gases that shoot out at high speed. This action pushes the rocket forward, creating the thrust needed to lift off. In rockets with multiple stages, each stage has its own set of engines and propellant. This design helps the rocket shed weight as it climbs higher. Once a stage uses up its propellant, it is jettisoned. This makes the remaining parts lighter and easier to accelerate. It's like dropping a backpack when you no longer need it to run faster. Different stages use different types of propellant suited to their environment. The first stage, which pushes the rocket through the thick lower atmosphere, often uses dense fuels like kerosene mixed with liquid oxygen. These fuels produce a lot of thrust and are easier to handle. The upper stages, which operate in near-vacuum conditions, usually use cryogenic propellants like liquid hydrogen and liquid oxygen. These are much more efficient but need special tanks and insulation because they are very cold and low in density. Propellants also affect how the rocket is built and managed. Some fuels, like kerosene, can be stored at normal temperatures and are simpler to handle. Others, like liquid hydrogen, need to be kept extremely cold in insulated tanks. This influences the design of the tanks, engines, and overall vehicle. There are different types of propellants used in rockets. Petroleum-based fuels like kerosene are common in first stages because they are dense and easy to handle. Cryogenic propellants like liquid hydrogen and liquid oxygen are favored in upper stages for their high efficiency. Hypergolic propellants ignite instantly upon contact and are used in smaller thrusters or for precise maneuvers. All these choices in propellant types and how they are used in each stage directly impact how well the rocket performs. They determine how much payload the rocket can carry, how fast it can reach orbit, and how reliable the mission will be. For example, the Space Shuttle used solid rocket boosters with dense propellants for initial power and liquid hydrogen and oxygen engines for the main ascent. In short, propellants are the fuel that makes each part of a rocket's journey possible. They generate the thrust needed to escape Earth's gravity, optimize performance for each stage, and make space missions successful. Without them, reaching space would be impossible.